Welcome, my friends. I'm so excited because in this video we get to talk about one of the most commonly used distributions, which is called the normal distribution. So let's go ahead and get started. The normal distribution looks something like this, where the higher parts of the graph represent more common observations. So that means observations closer to the mean, which is right in the middle, are going to be more common. And as we move further and further away from the mean, either lower or higher, the observations are going to be less and less likely. There are a number of characteristics that you should know about the normal distribution. Typically, we think of the normal distribution as a continuous distribution, meaning we can have whole numbers as well as decimals. The distribution is mound-shaped and symmetric about the mean, meaning that the distribution is a mirror image of itself on either side of the mean. We're going to think about area underneath the curve as representing probability, and the total area underneath the curve is going to be 1. Now, most variables are not going to follow a perfect normal distribution, but many variables can be described as approximately normal. For example, consider this histogram. This histogram does not perfectly fit the shape of the normal distribution on the curve, but it does approximately fit that shape, so we might say that this variable follows an approximately normal distribution. The empirical rule applies to normal distributions and consists of 3 separate statements. The first statement is that about 68% of observations will fall within 1 standard deviation of the mean. So if we have a normal distribution, we know that the mean should fall right down the middle. If we add the standard deviation once and subtract the standard deviation once, we will get 2 separate numbers. Based on the empirical rule, we know that 68% of observations in this distribution will fall between these 2 values. The area within 1 standard deviation of the mean is represented by these 2 yellow slices, which represents 0.68 or 68%. This means that there is a 68% chance of randomly selecting an observation from this distribution and for it to fall within 1 standard deviation of the mean. The second statement of the empirical rule states that about 95% of the observations will fall within 2 standard deviations of the mean. So that means if you take the mean and you add the standard deviation twice, or subtract the standard deviation twice, there is a 95% chance that we will find a value between those 2 numbers. And finally, the third statement is that about 99.7% of the observations will fall within 3 standard deviations of the mean. So if we take the mean and we add the standard deviation 3 times, or subtract it 3 times, we will get 2 numbers, and 99.7% of the observations will fall between those 2 numbers. A general rule of thumb is that it's pretty rare to have an observation on a normal distribution that is either more than 3 standard deviations above the mean or less than 3 standard deviations below the mean. We should expect about 99.7% of the observations to be within this range, so it would be quite rare to observe a value outside of this range. Let's look at an example. Suppose that the variable x follows a normal distribution represented by the capital letter N with a mean of 100 and a standard deviation of 10. Let's draw out the distribution on the graph. We know that the mean of the normal distribution should go right in the middle, so we can place 100 in the middle. If we're doing an empirical rule problem, then typically what you're going to do is draw 3 lines towards the right and then 3 lines towards the left. On each line, you should increment by whatever the standard deviation is. So what we can do is take 100, which is the mean, and start adding or subtracting 10. Adding 10, we will get 110, 120, and 130. And subtracting 10, we will get 90, 80, and 70. Based on the empirical rule, we know that 68% of the observations will fall within 1 standard deviation of the mean. That means that about 68% of observations will fall between 90 and 110. About 95% of the observations will fall within 2 standard deviations of the mean, which is between 80 and 120. And about 99.7% of the observations will fall within 3 standard deviations of the mean, which will be between 70 and 130. Alright, here is a problem for you to try. Assume the height of an adult male follows a normal distribution with a mean of 69 inches and a standard deviation of 3 inches. What heights for adult males will fall within the middle 68, 95, and 99.7% of the distribution? So go ahead and draw your normal distribution, put the mean right down the middle, and then count by the standard deviation to find all of the remaining values. And from there, you should be able to answer these 3 questions. All right, that's all I had to say about the introduction to the normal distribution. So hopefully you found it helpful, and I will see you in the next video.